Right, we're going to start some work on functions, and the first thing we need to do is actually define what a function is, which we've never actually done. Before that, you need to understand the different sorts of mappings. So there's 4 types. An example of the first one, so 1 is mapped to 3 by, I was going to say some sort of function, by some sort of rule. 3 goes to 5, and so you can see that we're just adding 2 each time, and so x will map to x plus 2. This is an example of a 1-to-1 mapping. So each value on the left is being mapped to a unique value on the right, and no 2 values here are being mapped to the same place. So literally each value on the left is mapped to a value on the right. Right, example 2. So 4 is going to 2 and minus 2. 0 is going to 0. 9 is being mapped to 3 minus 3. So in general, x is going to plus and minus root x. This is a 1-to-many mapping. So one value here is being mapped to more than one value on the right hand side. Like so. In a 1-to-many mapping, there can be elements which are 1-to-1, that's fine, but generally, for that one in particular, it's going 1-to-many. Each value on the right hand side here though is coming from a unique value on the left hand side, as in a 1-to-1 mapping. So let's try a different one. 0, it's going to go to 0, 45, 90, 135, 180. So 45 is going to go to 1 over root 2, 90 is going to go to 1, 135 is going to go to 1 over root 2, and 180 is going to be mapped up to 0. I'd obviously normally get you to tell me what this mapping is, but x here is being mapped to sine x. So we have more than one element on the left hand side being mapped to a unique element on the right hand side, and that is an example of a many-to-one mapping. And then last but not least, if I put down a few quadratics, so x squared minus 4x plus 3 is 0, x squared minus x is 0, x squared minus 3x plus 2 equals 0. If we map onto the roots, i.e. the solutions of these functions, then this one is going to 1 and 3. This one here has solutions at 0 and 1. And this one here has solutions at 1 and 2. And that's an example of a many-to-many mapping. So we've got more than one element here being mapped to the same element on the right hand side. So these two, for example, both mapped to 1. But we've also got more than one element here being mapped to the same value on the left hand side. So for example 1 and 2 both mapped here. So it's both one to many and many to one, which creates a many to many mapping. With functions, you need a unique value of y for each value of x that you put in. So for a function, you need to know where you're being mapped to, because otherwise it would be quite ambiguous. And so one to many and many to many mappings are not technically functions. One-to-one mappings and many-to-one mappings are. So I'll jot that down for you. So a mapping is a function so this is kind of your definition of a function. If there is a unique value of x, a unique value of y, sorry. If there is a unique value of y for each value of x. i.e. many to one and one-to-one mappings are functions. So you need to know where you're being mapped to. So I'll put that back on. Here, y equals x plus 2 is one-to-one, that's a function. Y equals plus or minus the square root of x is not a mapping, because you wouldn't know where you're going. Y equals sine x is a function. And if you're trying to find the roots of x, then yeah, roots of this quadratic, you end up with a many-to-many mapping there. Right, so just quick, I think I can fit this in. What sort of mappings are the following? So y equals x squared has more than one value of x being mapped to the same value of y. So that's many to one. So you've got like an overlap this way. Y squared equals x, so that's the same as y equals plus or minus root x really. But you've got one value of x being mapped to two values of y. So that's one to many. Y equals 2x minus 1 is a straightforward one-to-one mapping. So you get a unique value this way, unique value coming back. And this circle, we have one value of x being mapped to two values of y, but you also have two values of x, try and get this to look good now, being mapped to the same value of y. So you've got an overlap this way, overlap this way, and so that is a many-to-many mapping. So technically, y equals x squared is a function, y equals 2x minus 1 is a function, but these two are not functions. And I'll give you a few questions on that, just so you've got the idea.